Hey everybody, I'm John Lauer, and I've got a nice little treat for you here. I just got something from FedEx a couple hours ago. It's a new 3040 CNC machine. So what I'm going to do is I'm going to TinyG-enable this, and of course ChiliPeppr-ize the whole setup. These machines come with sort of a Mach 3 approach. They don't really come with the software, but they come with a board with a parallel port. Which of course nobody uses anymore. But the crazy thing is, I didn't really know these machines existed until a few months ago. These are hugely popular. I got into the CNC because of the Shape Oko, and I love the Shape Oko. In fact, I got two of them sitting right here in my workshop. But this thing, there's thousands more of these apparently out there, and they're really nice. So I'm going to show you why I went this route for my next setup. What it takes to TinyG-enable this thing to get a really modern setup. So let's get started. Okay, here we are with the 3040 unwrapped. It's really nice. You've got the Y-axis right here, and I'm able to kind of turn it pretty easily. You've got the X right here, which I can sort of equally turn, and it's really smooth when I do it. I'm just turning the nut on the side of the bearing over here. And then of course you got the Z. And so this is equally really smooth. In fact, I want to point out something. If I, there's no motors attached right now, but if I just sort of gently push on it, it actually slides down, which means I may actually have to leave my Z motor engaged when I'm milling, which you usually don't have to do on a lead screw. But because these lead screws are so smooth, and this has ball screws on it, not trapezoidal screws, so it has the higher end version of lead screws, everything just feels really smooth. And then of course my big test for how rigid a machine is always the can you move the tool head? And when I try to move this, it barely gives at all. In fact, I'd say, you know, I don't have a way to necessarily measure this, but it just feels super rigid. So, you know, there's still always going to be a little bit of give. The spindle feels pretty nice too. You can kind of feel the magnets as you do this, kind of catching. I'll rotate it around for you a little bit too. The drag chain I think is really nice. Typically, you know, this is something that you've got to do on your own to get set up. Again, this is where the motor mount goes. The connectors look pretty good. You get another drag chain back here, and then I'll see if I can tilt this up for you. Underneath, you've got the ball screw connector here, and for the Y. See if I can rotate that a little, and you know, we're kind of moving the whole machine. And then you've got the two rails that it goes along. These are pretty beefy looking, and you know, nice and oiled up there. So with the rubber feet on it too, I like that because that'll kind of help absorb. So let's maybe move to the next step here. Okay, let's take open this box here. This is the looks like the motors, and comes with some pieces. So you get 3 NEMA 23s, pretty standard stuff. I don't think there's anything super exciting here. The only thing that I do think is pretty cool is you get these the dual shafts, so you can still rotate. It looks like each motor does come with a little standoff, and these don't have to really support any weight, so those don't have to be that beefy. I think they're almost just more for protective. That's a really nice, thick coupler, and you can tell it's got the little spring action to it, and just got the little machine screws. And then those connectors, I like that these have the flex plastic on them, because you know, this is where you could kind of get friction over time. And there's even a rubber, that is really nice. There's a rubber sort of grommet right there to make sure that the motion doesn't affect that over time. So pretty cool. Okay, now we're gonna open the final big box that comes in the overall machine itself, and you get this controller, which we'll dive into here in a second. And then you also just get some extra final pieces. You get a parallel port cable, which we obviously aren't going to need. And then you get this nice little, sort of this nice little box of, looks like clamps and hex wrenches and some extra fuses. So that's pretty cool. And then the wrench to take stuff off the spindle. And then you do get a little touch probe. The touch probe's pretty nice because you can use that to offset your workpiece. You set it on the top, the end mill comes down. The moment there's a conductive connection, you're good to go. So you got to connect that to the end mill. And I've shown some tricks how to do that with ChiliPeppr today in the TinyG and or Gerbil. But it's cool that it's got an integrated piece. And then really, this is the controller that we'll do a little walkthrough on it. But you've got power, you've got the spindle on-off, and the e-stop. So that's kind of fun. I've never had an e-stop. But this is the spindle speed control. But I would do that through the TinyG PWM. So we'll see if we can get that working. Okay, let's see if we can get the power going. It just comes with a standard power connector on the back here. And when I mean power, I just mean try and maybe get the spindle going. Just to give you a quick glance, you've got the infamous parallel port. I really do find that laughable because nobody does parallel ports anymore. In fact, they're just impossible to find. XYZ, these are nice aircraft connectors, or I think that's what they're called. You've got a little manual or automatic switch for your spindle control. You've got the probe port for this little guy. And then the spindle. So let's just plug in the power. And then you get these connectors, and they are labeled pretty nicely. This is Y. This is Z, X, and that's the spindle. So let's actually connect this in. I'll skip the XYZ for now because it's not even, I don't have the motors connected, but I want to just see if at least the spindle fires up. And then let's go ahead and switch power. I hear the fan go on in the back. And then let's try the spindle. We'll go slow. Oh yeah, it's working. And then let's crank it. Sounds great. Sounds really smooth. Okay, well good. So at least we proved, oh, let's try the e-stop. Okay, so e-stop must, oh, interesting. I was on, oh, I see. I'm switching the back for manual. I see. M maybe means machine and H means human, is my guess. And then you would think that that would stop the spindle, but it doesn't. Oh well. That takes a little bit to react. And then we'll just completely shut it off. So, all right, we're going to open this up. I'll disconnect the power from it. And then there's just some screws along the front. I already took a couple out. So there's 4 along the front here. And then you've got 4 in the back. So here, let me disconnect that spindle for now. Nah, I'll leave it connected actually. And then we'll take this this screw out right here. Come on. There we go. Set that aside, and then we'll pop the top off here. So let's take a look inside here. You've got a pretty large toroidal transformer. So you can get a focus on in there. And then you've got all sorts of fun circuit boards going. You've got sort of the... you've got... I guess really this is the equivalent of the TinyG right here. And then this is where the power's coming in. Okay, so the goal is going to be to take this TinyG board, this is actually the TinyG V9, and put it right here where this board is, because you've actually got the connectors. This is the Z, this is the Y, and this is X, to the stepper motors. And what's really amazing, you guys, is that the connectors go right in to the TinyG for the most part. They're not perfect, but they're both Molex connectors, and they just slide right in, which it's as if this box was made to fit the TinyG. And then even the amount of power, which I'm going to pull off right now, this is 24 to 30 volts, and on the TinyG it expects 30 volts with a minimum of 12, so that's going to work perfectly fine. You know, this connector isn't going to be exact, but I could maybe just do a little copper jumper off of that or something. Still got to get that USB, but maybe I can make it fit through the parallel port. So I'm gonna disconnect this. There's one more wire on here, which is the PWM control. So the hope is that that PWM directly fits into the PWM out on here as well. And the fan, I know you can control the fan off the TinyG, but the fan on this is hooked into this power board, so we should be okay on that. And then the E-stop, I think we could connect that to the reset switch here, where it just kind of mimics a reset. And there are some pins there that I should be able to solder in a little jumper. So not a lot of extra work to kind of tweak this to get ready, but I'm going to remove this now. Okay, so just about got it out. I've got 3 screws, 1, 2, 3, 4. I only took 3 out. These are these Toshiba chips that are connected to the heatsink just through some screws. And then there were 1, 2 screws over there. And then I had to remove the little parallel port screws and then just kind of lift this out. So take that out. And there we go, pretty simple. You can see these are pretty beefy XYZ chips. But I do like that there was this heatsink, sort of conductive double sticky tape, because you've got these 4 controllers here. Let me move that out of the way. And it'd be nice to just kind of go direct there. They did have a couple of spacers right here that I don't know if we'll need them. I'll kind of think about the best way to put this back, but it would be nice to somehow attach these to the heatsink, or maybe add some extra, chunk of aluminum underneath one of these, all of these, to kind of, use that same sticky approach. But it's not super necessary. My understanding from talking with the Synthetos guys is that the heat management off these chips is pretty good these days, especially since you get that fan right there, so it might be fine just going direct. Okay, so I'm making some good progress, but I need to get this USB cable to fit roughly right here. If I could put it in, it actually slides through the parallel port, but I really need it right here because the TinyG mounts great. So I'm just going to have to drill out a hole or try and, extend this parallel port slot right here. Okay, so I took the heatsink that was in the base. It was right in this base. I just kind of popped it out. It just had 2 screws in the bottom. these little guys there. Anyway, I took it out because the board fits really nicely right on it. And in fact, this hole lines up pretty nice with a little M3 screw that they give you. And this hole doesn't quite line up, so I'm not going to use it. Okay, but what I'm doing now is I'm sizing it, and I'm going to drill a hole here on this hole in the TinyG and a hole here. And I have a little drill with an M3 tap, so I'm just going to do, you know, a little hole here and a little one there just to connect. Now I'm doing something kind of creative. TinyG comes with these little rubber feet, and I'm going to do it so that the rubber feet kind of line up right about there. And then I'm actually putting, I had little chunks of aluminum. I'm putting these right below the heat sink for each of the chips, just to get some contact with this nice, really nice heat sink that they gave. And that should apply pressure. And it came with this little conductive tape that was, that's going to go right here. And that conductive tape was actually right beneath these original guys on the original board. So pretty good use of this. And I think I'll have a really good setup. So I'll let you see how it progresses. Okay, so here is my finished product with the TinyG board on this, and if you can kind of get a feel for what's going on in there, there's actually little blocks of aluminum that I kind of had handy. I actually kind of just trimmed them on the Dremel, but you'll see that that conductive tape, sort of heat conductive, I got in there, and then you know, those two screws kind of hold it tight. With there's a little bit of curvature to the board if you kind of look, not much. I'm not trying to put any real pressure on the FR4, but then this pulls down here with a little bit of give. I put the rubber feet that come with the TinyG under it, but I'm really happy. And now I'm just gonna mount these two holes that it came with. I'm just gonna mount it back. So it's essentially going to fit you know, right in there. And the, well, I'll show you when it's done. Okay, that's in there really nice. It's screwed back in. The USB cable goes right in the back with that little port that I milled out of there with a little Dremel tool. And now the last little step here is to take the e-stop switch, which I soldered in just a little 2-pin header, kind of a standard 2-pin header, right next to that reset button. Fortunately, Synthetos thought forward to maybe have a situation like that, and now my e-stop should work fine. So I am pretty much set up here. I've got my power right here coming out of this main board, and I've got XYZ steppers connected. The only thing I might try and actually do is hook up the probe right now, because when I know I'm going to use it. And the probe, I do have a DC barrel jack somewhere in my workshop, so I may just do a little rig here where it connects in, or maybe I'll even unsolder the one off of, off of this board, this guy. So, yeah, pretty much almost there. Okay, moment of truth time here. I've got a lot of stuff set up. I've got the e-stop connected, I've got the power connected, I've got Z, Y, X motors connected, and I actually have these, I've got them connected into here. All three are actually attached now to the TinyG in here, and I'm going to turn the power switch on, and lo and behold, the lights come on, so I'm getting power in through there. I've also got USB connected to my laptop right here. And if now that it's on, if I hit reload, it's seeing the TinyG in my serial port JSON server. So I should actually be able to connect. And if all goes well, I should be able to run this right now. So let's go ahead and I'll hit play, and it's working. I've got the lights out blinking, well, not really blinking, but I've got the power going. I've got this motor spinning. I've got Z going. And I've got the Y-axis going, so we're in good shape. Now, let's test the E-stop. Works brilliantly. I've never had an E-stop, so that's pretty exciting. That works great. So really close. Next step now is to try and hook up the PWM control for the spindle. Also, by the way, the heat sinking on these chips feels really nice to be able to run it at really high amperage because of the massive heat sinking going on here. Okay, I'm going to go ahead and put these stepper motors on now. They've got these M5 screws. They've got these plastic holders, which don't really do any like support other than they make sure that the spacing's correct. And then you've got to you've got to tighten down these little couplers, these little flexible couplers. So let's get going on that. Okay, we've got pretty much a finished product here. If you can tell, I actually put my BeagleBone Black in here, and I've got Ethernet running out the back. I've got the power cord, the 5 volts for BeagleBone running out the back. I have the USB connector for the TinyG, kind of looped around in here to make sure none of these wires touch any of the conductive traces on the TinyG. So I'm just kind of using the coiled up USB cable as insulation. It's not the best setup. I'd rather build some kind of enclosure or some kind of spacers, but for now it's just, you know, generally resting in here so that I could, you know, put this lid back on. But the cool part is I have ChiliPeppr loaded, and the BeagleBone Black, you can, let me actually disconnect here. You can go into the Your Servers tab, scan for your hosts, and of course I puttied into the BeagleBone Black, and I'm running the serial port JSON server. So I'm connected, and I'm going to go ahead and jog around a little bit, and we are moving. So I'm going left and right. Now I'm moving back in the Y and forward, and then the Z is working. So I'm going to go and run the ChiliPeppr logo. This is sort of our maiden voyage run here. I'll get out of the way a little bit. BeagleBone Black running, ChiliPeppr running, TinyG, everything's looking good. Now I got to do some tuning. I haven't really tuned the exact travels per revolution yet, but I can get that calibrated and pretty much be ready to go. So I've got myself a fully working 3040 Chinese CNC machine with ChiliPeppr, TinyG, BeagleBone Black, and a beautiful setup.